Hi everyone, welcome to this short online presentation of our paper called Modeling Eye Tracking Data in Comparative Judgment. Our group is doing a lot of research on comparative judgment. The main idea about comparative judgment is that you use the framework of this kind of task that judges, when they have to assess the quality of, for instance, in this case, argumentative texts that are written by pupils, they have to compare two texts rather than to rate it or give it scores and anything like that. We have done some data gathering experiment on putting people or judges behind an eye tracker while doing this kind of tasks. And now we have a challenging question: how to model this kind of data. Because if you have a quick look on what's happening, and you can go to the YouTube movie yourself if you want afterwards. In this movie you see the eye gazes of two judges, two separate judges, and you can see some differences in the process. At the top you see that there's a judge who is visiting both texts, short parts of the text in both cases, while at the bottom you have somebody who is doing a lot of reading in the left text first and then goes to the right text afterwards. And this made us wonder whether these gaze duration data of visits in one or both texts may come from different kind of cognitive processes. You can distinguish a process like something like scanning, having a quick view of both texts, some major characteristics of both texts, like the structure and so on. So it's it's another cognitive model than really reading a text, a thorough reading of a text to get the idea of the whole argument that is being put up by the writer, by a pupil. So that's a different kind of cognitive process. And how, if you, for instance, are interested in the question how judges differ in reading for text comprehension, how to decide on which kind of data to use. That's a triggering question because somehow you want to acknowledge in your analysis, and when I say analysis I mean statistical analysis, you want to acknowledge that both processes may be in play, or maybe a third or a fourth process if you have some more theory about the whole idea here. But you want to avoid, when doing the data analysis, to have to come up with some kind of threshold for which you decide, this kind of gaze event duration comes from really reading thoroughly the text, so from a text comprehension process, and then another one comes from more like scanning, because that's a very difficult question. And also you want to avoid aggregation, of course. But that's the goal of the presentation that I want to do today, is show you models that acknowledge both processes in one single model. The data that we will use comes from an experiment where we had 26 high school teachers put behind the eye tracker, each of them that did 10 comparisons of two argumentative texts. This is about the design, so we have different areas of interest that we can distinguish in this setup, but we will use mainly only the data coming from area of interest called the left text and the right text. Data looks like this. We have multiple observations for each participant and each comparison. So we have participant 2 doing a certain comparison, and we have a recording of that participant, a visit of that participant in the left text. That was 1.6 seconds. Then we have another recording, and so on and so on. The data that we will use are the log transformed data. These data are somehow nested within the combination of judges and comparisons. And that's something you can acknowledge in a mixed effect model, and it's written out here. So our dependent variable are the durations, case event duration of a visit to an area of interest, one of both texts. We can assume some kind of intercept, overall average duration, and an effect of judges, an effect of comparison, and some residual variance. That's the simple mixed effect model, and that's the first model we will show. But the more challenging and interesting model that we want to show is the idea of a finite mixture model that's combined with the idea of a mixed effect. So that's why it's a mixed effects finite mixture model. And the first thing that we added was that there are two processes in play. That's our assumption in this model. And a process that is captured by this part of the model, and a second process that is captured by this part of the model. But we have two processes, so in this model we assume an intercept for the first, an intercept for the second process, so a duration of an average visit coming from the first process, the duration average duration for the process coming from the visits coming from the second process. And in this specific statistical model too, we assume that mainly, and this is what we will call text comprehension, the second one, is dependent on judges and comparisons. A similar model, also a finite mixture model, but saying, hey, the reading for text comprehension, and it's a naive model of course, is not dependent on judges or comparisons, but the scanning. So the first process is dependent on judges and comparisons. And then a fourth model, which we will we will test as well, is where we say the gaze event durations of both processes can depend on judges and can depend on comparisons. We used Bayesian estimation. I can give information about that when the discussion is online during the conference. But what we will show, I wanted to show you, is the comparison of the models. And to make it a bit more complex, I didn't label those models that well. So we have our four models, and the fourth model, the most complex model, is called Model 3. And Model 3 fits best. So we can assume, given our data, that there are two data generating processes, and that both processes are different, so the durations coming from both processes are different or dependent on judges and comparisons. I want to quickly show you what comes out of this kind of model, so what is the kind of output. First one are those two intercepts, so an estimation of the average time, or in this case the median time, that is used for scanning. So a visit that comes from the scanning process is on average 0.44 seconds. It's originally modeled in a log data scale, but are recalculated to seconds. And 80% of the estimations fall within this kind of range, and text comprehension on average is about 8.10 seconds. So a visit coming from this process is on average, or a median estimation of that, is 8.10 seconds. That's kind of the first type of output you get. You also get information on the proportion, and we can see that most or the highest proportion of the gaze events come from, according to our model, comes from scanning behavior or the process of scanning, and a lesser amount of gaze events recordings come from comprehension. We can also get an idea about the impact of judges and comparisons on both processes. For instance, judges have the highest impact on reading, or the biggest difference that we see between judges is on text comprehension reading times. We can also get some estimations of each individual judge. For instance, for text comprehension, we have judges taking more time to read or to show longer visits and shorter visits while reading for text comprehension. We can do a similar thing for comparisons and so on. Voila, this is the presentation that I wanted to show, or the data analysis that we wanted to show, and let's skip the conclusions. What I would like to discuss with you when we're in the early conference is what about more than 2 processes, because we made a decision about 2 processes, but maybe there are 3 or 4. A more technical question is on the priors that we used. It's a very technical story today, but what about the need for a triangulation? I can imagine that you can come up, or we can come up with very good ideas for further on research where we triangulate this kind of data with other data to get a better understanding of the different types of processes. What about if in this comparative judgment task the text, they didn't have to compare text but something else, like pictures that were made or a poster that was made by students and so on. How specific are our models for the task? And then something I really want to discuss with you or think together with you is about other applications of this kind of finite mixture modeling when you have to model process data. And whether you see some possibilities of this kind of analysis in your design, your study, your field of research. That's about it. I hope we can have some interesting discussion online at the early conference. If you have any questions, do not hesitate to contact us, of course. All the material is also available on Open Science Framework, so you can find a lot of the data and so on there, and the scripts we used and so on. Thank you for your attention, and hopefully we see each other online at the conference.